Geometry, Notes, Transformations, Section 7, Dilations. Up to this point, we've talked about translations in detail, reflections in detail, and rotations in detail. What do all three of those have in common? They are isometries. They produce an image that is congruent to the pre-image. It is also known as rigid motion. Dilations are not isometries. They produce non-isometric figures. They are not congruent. It is not rigid motion. This will result in similar figures. Dilation results in similar figures. Dilate triangle fat by a scale factor of 2 about the origin. Here's what that means. Scale factor of 2 about the origin, we're going to move all the points 2 times the distance from the origin. So here's how that would look. And there's different ways that we can do this, different orders that we can do this in. I'm just going to try to explain it a couple different ways. A is to the right of the origin by 1. If we double that, A prime is going to be to the right of the origin by 2. F is left 2 and up 1. If we double those numbers, we're going to go left 4 and up 2. So F prime would be here. T is left 1 down 2. If we double that, that's left 2 down 4. That would give us fat prime There's some things that have just happened that make this pretty awesome. For one, if you were to draw a line segment from the origin, which is the point of dilation, through A and A prime, through the origin F and F prime, through the origin and T prime, in each of those cases, you end up with 3 collinear points. So in other words, origin A and A prime are all collinear, origin T and T prime are collinear, origin F and F prime are collinear. If that ends up not being the case, you've certainly made a mistake. Something else that's true when you do these dilations, the pre-image and the image corresponding parts are parallel to each other. Happens every time. Why does that matter? Well, when you look at your answer and you want to say, does this answer seem like it could be right? If things end up not being parallel, there's no way it can be right. How could we have done this algebraically? Well, a scale factor of 2 about the origin, we just take these ordered pairs and multiply each one by 2. So that's negative 4, 2. It's 2, 0. It's negative 2, negative 4. I just multiplied every number by 2. Check out number 2. Dilate triangle fat by a scale factor of half about the origin. So I'm going to do this in a different order than I did the last one, just to show you what's up. If I were to draw from the origin a dashed line through F, F prime has to be on that dashed line someplace, that red dashed line. If I draw a dashed line from the origin through T, T prime has to be on that line someplace. If I draw a blue dashed line from A through the origin, A prime has to be on that someplace. Specifically, scale factor of a half, this shape's going to get cut in half. So I will go down here and do it algebraically first, and then I will do it in my picture. If I cut these coordinates in half, that's going to be 5 halves and 4 halves, which would be 2. Be negative 2 and 1, it would be 0 and negative 2. If I plot those points in my coordinate plane, 5 over 2 is the same as 2.5, 2. Notice it's right on the segment that it's supposed to be on. That is F prime. A prime is negative 2, 1, right on that line that it's supposed to be. And T prime is 0, negative 2. right where it's supposed to be. I connect those points, make a triangle. You want to color it in for your own viewing pleasure, do so. So number one, scale factor was an enlargement. Number two, the scale factor was a reduction. Number three, this one's going to get a little crazy. Dilate about 0.0, here's 0.0, by a scale factor of 2. If we were to measure the distance from O to A, we would have to double that distance to get to A prime, double the distance from O. Same thing from B to B prime and from C to C prime. So what we could do for this is, first of all, draw a segment that goes from O through A segment from O through B, a segment from O through C. Our new points have to lie on those segments. If I count spaces, I go up 2 and to the right 3 to get to A. So if I do that again, or if I count from the beginning, up 4 to the right 6, that gets me A prime right here. B, I go up 1 to the right, 1, 2, 3, 4. So if I go up 2 and to the right 8, C is down 1 to the right 2, or I could go down 2 and to the right 4. That gives me this image, ABC. It is twice as big. The dimensions of the sides are twice as large as the original because the scale factor is 2. Corresponding angles are the exact same, and that's because these are similar figures. Would like to point out once again that AC is parallel to A prime C prime. AB is parallel to A prime B prime. BC is parallel to B prime C prime. Same is true of this previous problem. Corresponding segments are parallel when you do a dilation. Number 2 is getting a little crazier. We're going to dilate around 0.0 by a scale factor of 2, triangle ABC. So I like to once again extend these lines. You can make them dashed if you want. You can make them solid if you want. Dashed is likely better. I'm extending it from the point of dilation through each of the vertices. Now by doing that, I know that each of these image points has to be on those lines. So for example, B is to the right of O by 1, so B prime is going to be to the right 2, because the scale factor was 2. A was 1 above, so A prime is 2 above. C is 1 left and 2 down, so it's going to be 2 left and 4 down. Color it in if you want. Don't color in if you don't want. It don't matter to me. And then once again, these are parallel. These are parallel. These are parallel. When you do a dilation, it creates similar figures. Number 5, we're dilating about point A. So if we look at what we've done, well, let's not look what we've done at this point. Point A is actually a point on the pre-image. So what's going to happen there? Well, A prime is going to be in the same location because A is 0 units from A. If you double that, double 0 is still 0. C, it's left 1 and down 3. So if we go left 1 and down 3 again, it's going to put C prime right here. B is down 1, right 1. If we do that again, because it's doubled, it's going to put B prime here. So our triangle, the dimensions are twice as big as the original because we dilated it by 2. Number 6, well, this is interesting. What do you suppose it means when it says dilate it by a -2? Everything we've had so far has been a positive. This is dilating by negative. Well, it means that we're going to go on the opposite side of the center, the point of dilation. So the distance that A is from O is down 2 to the right to the left 2. If we double that, it's going to put us all the way down here, A prime. B is down 1, left 3. If we double that, down 1, left 3, down 1, left 3, it's going to put us all the way over here. C from O, we have to go through it and then double that distance. That's going to put us here. So that gives us this fella. A lot of lines on here, so if I could shade this, probably good, so I can clearly see where my image is. Number 3, this is a really important concept here that we've been talking about, is that when you dilate something, things that are parallel to each other are preserved. The thing that you're dilating, its slope doesn't change. A slope of AB is the same as slope of A prime B prime. So if a BC is the same slope as B prime C prime, and the same for the last side. So if we're going to dilate M about the origin, our image is going to have the same slope as our pre-image. It always will. As far as the distance from the origin, you can count it in lots of ways. Let's say you count it to the y-intercept. If you triple that, instead of being 1 away, it's going to be 3 away. What's the slope going to be? It's the same as the original. So whatever the slope is here, we translate this down. Oh, I'm sorry, if we dilate it, it's going to have the same slope. So this is M prime. Same slope as the original. Check out number 8. Dilate y equals -1/2 x plus 4 about the origin by a half. Now, y prime, our new line, will always have the same slope as the original if it's a dilation. So it's -1/2 x. What's affected is the y-intercept. We're cutting that in half. What's half of 4? Half of 4 is 2. So our original graph looks something like this. This is y equals -1/2 x plus 2, pardon me, plus 4. And our new graph it's dilated by a half, so it's half the distance from the y-axis. So y-intercept is 2. Now, you don't have to use the y-intercept for this. You can use any point. This point here was 2 to the right and up 3. If I go 1 to the right and up 1.5, that gets me this point. I guess if I wanted to make this a little more accurate, well, I can't. When I say accurate, I mean these points that you see here don't necessarily correspond to the points that were up here. Long story short, it's the same. When you dilate a line, it's always the same slope. You just take the y-intercept and multiply it by the scale factor. Number 9, we're going to dilate line M about the origin by a scale factor of 2 to get M prime. So the slope is going to be the same. The slope is up 1 to the right, 1, 2, 3, 4, 5. The y-intercept here is 2. If we double that, it's going to be 4. And then the slope is 1/5. Same slope. Y-intercept changes. Determine the scale factor and the center of dilation. Now we could do this the hard way. The hard way is use the distance formula, find the length of BC. Use the distance formula, find the length of B prime, C prime. It's completely logical. Go for it. Takes a lot of time. No one wants to do that. Let's find the center of dilation first. The center of dilation can be found by taking a segment and extending it from A prime through A, B prime through B, C prime through C. They will always intersect at the same spot. Whoops. So the center of dilation is at 0, 2. As far as the scale factor goes, we don't have to count diagonally. From the center to C, it's to the right 2. From the center to C prime, it's to the right 1, 2, 3, 4. It's twice as big. Scale factors 2. And count in other ways as well. To go from the center to C, we go down 1. To go to C prime, we go down 2. It's doubled. To go up to A, you go up 2. Up to A prime, you go up 4. It's doubled. To the right to A is 3. To A prime is 6. It's doubled. We could do the same thing with B. 11 and 12. Determine if the dilation is an enlargement or reduction. The scale factor is 3 to 2. 3 to 2 as a fraction is 3 over 2. Is this number bigger than 1? If the answer is yes, and it is, it's an enlargement. Is the scale factor of 6/11 bigger than 1? Or is it smaller than 1? It's smaller. So this is a reduction. All right, that concludes the notes. Please do T7 homework.